back to my series on patching the generative Polykrell. In the last few episodes, we've looked at how I've been using multiple synced sequencers, moving very slowly in the background to modulate the modulators of our 5 Krell parts in their voices in order to be able to create some form out of this whole patch that we've got set up. And so there's a couple of extras that I've added in that I wanted to walk through in this episode. So one of the things that I've done differently from the original patch is down in here. So I'm using the attenuator on the bottom left-hand corner of the double Andore to attenuate the voltage that comes out of the Pittsburgh sequencer that we see here is on step 3. Now the Pittsburgh sequencer voltage was previously generated by the Dope for Ribbon controller, and that was our original form control voltage for the whole patch. Now what I'm doing is I'm using the Pittsburgh sequencer to control the rate of all of the Krells and some of the other parameters in the patch, such as, for example, the scale type from our IntelliGel U scale. But I'm also taking that voltage and attenuating it with the double Andore VCA, and then I'm patching it into an IntelliGel linear mixer, and I'm adding, using that mixer, the output of the triangle LFO that drives that quantizer. And so the reason that I'm doing this is that then, as the Pittsburgh sequencer steps its way through its voltages, its voltage output is summed after being attenuated with the output of the triangle function generator, essentially offsetting it before it's patched into the U-scale quantizer. And this has the effect of changing the range of the 1 volt per octave CV that's coming out of the quantizer. So I'm able to push the whole melodic and harmonic output of the patch by altering CV coming out of the Pittsburgh sequencer. So this means that for each of the 8 steps, I can set a level that not only dictates the speed of the whole patch, and as we can hear now, it's slowed down because this voltage on the Pittsburgh is lower, but I can also change the range of pitches coming out of the whole patch. And I purposefully have those all coming from one sequence so that there's a correlation between the speed that the patch runs at and the range of pitches that it outputs. So the slower that the Krell function generators are running, the lower the pitches that are going to be coming out of our U-scale quantizer. Now we can see some of this in action if we look at the scopes. So the very left-hand scope is running our melody voice and our counterpart voice, and we're listening to those two. We can also hear the bass in the background. The middle Dope for VU meter is now showing us the output of the Pittsburgh sequencer, so that's showing us what that rate voltage looks like, and we'll see it move up and down in steps through 8 different steps along with the Pittsburgh sequencer. And then the far right scope is showing us the output of the double Andore triangle function generator that drives the quantizer. So we'll see that triangle squish and get faster like it is now, or we'll see it stretch out and get slower when the Pittsburgh voltage is lower. So it gives us a sense of what's happening melodically. So we're just going to revisit our Klee sequencer, and the B side of Klee is what's controlling our bass voice. So, like I had explained in a previous video, the output voltage of the Klee controls the gain of its oscillator going into the filter, and so that's what we're hearing from the bass voice. But you may recall from previous videos that the bass voice has a very unique, almost logic subpatch running that controls the way that it grabs pitches from the sample and hold that is also driving our melody voice. So if I turn the counterpart voice off for a sec, so now we've just got melody and bass running. Please like and subscribe to my videos. Please consider joining my Patreon to help me make more videos. And we'll see you next time.